So because we don't have we cannot express as this is not a regular, say a regular shape. So we try to do some approximations. So this is the problem. So find the area under the graph or the curve x square for x between 0 and 1. The thing here is this is not a regular area. Where we can find the area. We has a there's a formula for area is available. Okay, so let's just do approximations. So if you cannot find the precise thing, then let's do approximations. And let's try to improve the approximation as possible. And somehow try to find a general scheme to do approximations. All right, so approximations. Using regular shape. Okay, so what is easy regular shape? The easiest one would be rectangle. Okay, so that's the easiest one because the formula is just base times height. Okay. All right, so this is the approximations. That's one. Let's go. So this area over here. So we need red area. Right. So we try to approximate using, say in this case, a square. Approximate using square. Green one. Okay. That's the okay. So these first approximations, say approximate area, say A is one because this is one, this is one. Okay. And from the picture, you already seen what is if you have approximations, then automatically you have errors. Then you cannot avoid from errors. Okay. So here's the error. Error of approximations. Okay, you see that this is not a good approximations because the error is even bigger than the area that you want to get. Okay, so this is not a good approximations, but somehow can you can we make an improvement? Okay, so say this is just first approximations. Okay, so this is the first approximations. It's okay. Okay, so this is first approximations. Let's define a second approximations. How we do approximations. Okay. All right. We want to use a rectangle, but now we use, instead of one rectangle, we use two rectangles. So the approximation is this one. First rectangle, and then second rectangle. Okay. So this second approximations. There's two rectangles. Okay. So the approximate area A2. Okay. All right. So this is the sum of the two area of the two rectangles. So the first one is, let's see, this is of the base length 1/2, and height is, let's see, well, because this is square, this is x is 1/2, then this should be 1. And the second one is the base length also 1/2, but the height is 1. Okay? Easily you can compute this is 1/8, that's 1/2. So this is 4. Okay, so that's the all right. Uh, what should be? Oh, the error. What is the error of those approximations? The difference, right? So this is the difference. That's the error of the second approximations. Can you compare to the first one? Which one's better? Which approximation is better?
Second,
Second. Why did you say the second one is better?
because it takes less area, I guess, because when you use one square, you're also accounting for the not the graph, like outside the graph.
Yeah. Less area of what?
Of the x1 and y1. Yeah.
Error. Smaller error than the. All right. So this is what we call the error 1. Right. So this sum is the error 2. Okay. So in this sense, second approximation is better. Than the first one, because the error is less than the error of 1. Okay? Smaller error. Okay. It's not exact, but then it has smaller error, so it's better. Okay. All right, so let's do the third one. The third one should be, let's see. All right, so let's, one is here. So let's divide to, okay, stretch the x-axis. Then you have the stretch picture here. So instead of two, we use four rectangles, third approximations. Use four rectangles. So what are those rectangles? One is this. So this is 1/2, 1, 2, 4, 3, 4. Second one is this one. Third, fourth. Okay, so the first one is of height 1. This is of height, let's see, you square it here, okay, 4. So this one, this is 1/2 square, and this is 1/4 square. Okay, so the approximate area is, let's see, smaller one. So this is of base length 1/4. Okay. And height is, base length is same 1/4, but the height now is 2/4 square. 1/4, 1/4. That's but you can compute this one. Okay, so this is 1/4 square. Yeah. Okay, you compute this one. And think about what about the error? So this is the error. How would you compare the error 3 compared to error 2? Just from picture. Okay, how you compare that one? Let me throw the just get area. All right, so E2 is this one. That's E2. And E3 is this one. So this is E3, right? So the difference between E2 and E3 is this area here. Sorry. Oh yeah, that's correct actually. This is the difference. This is the difference. We don't have this. Okay, so this is the difference. Okay, so in this case, E3 is smaller than E2. So E3 is better. It's a better approximations. Okay, and let's continue this one this time. So what you guess, how we should proceed? The fourth approximations. How we should proceed with the fourth approximations. Okay, what do you do with the fourth approximations? Hello, are you with me?
Yes, sir.
Yes,
I'm
sir.
still thinking of an answer.
All right, so what do you do with the fourth approximations?
Do more rectangles.
Do more rectangles. How many rectangles now?
8.
8. Right, so just the we just have one big rectangles, which is a square. Now, second, you have two rectangles. Then you have four rectangles. Then you keep dividing the old rectangles here, the older rectangles, the previous rectangles, to two. Okay, so let's divide this up. Okay. So then what you have is this one here. Okay. Okay, so the approximate area, okay, so each length is, of course, 1/8. This is 1/8, this is 2/8, this is 3/8. Okay, so 1/8 square, 2/8 square, ongoing. In the end, just one, because that's 8/8 square. Okay, and then, well, you see what's the error? Even smaller than from here, the error. E4 is even smaller than this. Okay, so the fourth approximation is better. Okay, and let's see. If we have the nth step, can you guess what's the next one? How you describe the next approximations? From the fourth one, how would you get the fifth approximations?
Even more rectangles.
More rectangles, but how many more? How to get the
A
fifth from the fourth?
multiplication of 2.
So how many?
16.
16, because we keep dividing this. Okay. Okay, so keep defining. Okay, so you get AM equals what if that? So this 1/3. So this would be uh, the nth approximations. Would be as observe the length, base length. Here's the base length is 1, right? Then the base length become 1/2. Here the base length, the third is 1/4. The fourth is 1/8. 8 is 2 to the 2 cubes, right? Power of 3. It's going to be okay. All right. So what is this? On with errors. Not complicated, but for computer, this is easy. You just need to program, and then you get the numbers. All right. So that's basically the idea. Okay. Let's do something a little bit that we can compute here. We can compute explicitly because with this one, it is not difficult yet, but let's see how we do this one. Slightly more complicated. Okay. Uh, these tricks make it easy to see the errors getting smaller. So observe that the n gets smaller as n gets larger, meaning that uh, the approximations is getting better. Okay, so this is the idea. Um, if you cannot get the precise thing, you can do approximations. Good approximations, meaning that you always improve the approximations. Okay, that's what we call a good approximations. We can always improve the approximations. Improve meaning that they make the error smaller, right? So let's do something slightly better, not slightly better, but something easier. Okay. So let's make the divisions like this one. Mm, so something that we can recognize the formula, right? So like this. Uh, other approximations. So this is the first approximations. A1 is 1. The second approximations is this one. So A2, 1/2. Okay. And it's the same thing as the before though. A3. Now instead of keep dividing into 4, we just make division to 3. The note is stuck. So I have to see. Okay. Okay, it's stuck. Hold on. Okay, so this is 1/3, 2/3, and this one. So A3 is base length is 1/3. Okay, the height. The smallest one is 1/3 square. Okay. The second one is the 2/3 square. And it's just 1. Okay. The fourth one is we define the 4. So 1/4, 2/4, 3/4. And so A4 is, let's see, okay. All right. From this series of observations, A2, A3, A4, can you guess A5 without referring to a picture? What is A5? Read me on equations. What should be at A5?
One over 5.
1/5. All right. So what's inside the parentheses?
1/5 squared.
There. Next.
2/5 squared.
That what's the almost the second last?
4/5.
Yeah. And this is just 1. 1 is this 5/5. And all right, then let's do this. Let's jump to AN. Can you guess what AN is?
1/n.
1/n. So inside the parentheses. What's the first one?
1/n.
Square. Second,
2/n square.
right. 3. All right. Dot, and then second last.
N minus 1/n.
So this is 1. Let's just say N/n. Right. So let's simplify this a little bit. So this is 1/n. And well, you have all squares here. And you have 1 squared, 2 squared, 3 squared, dot, 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 n minus 1 squared plus n squared. Right? And so this gives you, let's see, 1 over n. There. Okay, so somehow, can we simplify this one? So that's the equations here. Can we simplify this one? All right, so let's do some formulas here. With some formula. All right. Now, if you add a number, let's say 1 plus 1 plus 1 plus dot, 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 1 nth term, what you get here? What is the sum? You're adding 1, 1, 1, 1, 1, nth term, n terms, I should say.
1 times n.
1 times n. Okay, now let's do some, like something increasing. So 1 plus 2 plus 3 till n. Anyone remember this formula here? Let's do some observations here. If you look at this 2, see the sum, n1 plus n. I should add n minus 2, n minus 1, and then n. And what you observe is that this one here. And then you observe also this. And then also this. What is the similarity? What are the similarities? So, 1 plus n. Right? So if you sum these two terms, what you get?
They all add up to n plus 1?
N plus 1, right? So you like a grouping by 2, right? Okay, so each pair gives you n plus 1. Okay, so the thing is, how many pairs are there? N over 2. Okay, what's the sum of the two numbers? N plus 1. That's the sum. Okay, you can check using induction. Yes, show that this is true. And because use induction. What is induction? Remember that you probably learned this in even before high school, in junior high. Let's see. For induction, for n equals 1, first check n equals 1. The left hand side is just 1. Right hand side, if you plug in 1, then you get 1 plus 1, 2 equals 1. They're equal. Okay, that's true for correct for say. Okay, and we suppose this is 3 steps. Suppose the formula is correct for n. Okay. Now the question is it correct for n plus 1? That's the question. Okay, so then how we do this one? All right, so let's 3 plus until n plus 1. Okay, how to think about this one? Well, let's put the this together until n, and then add the n plus 1 separately. We know from this what you suppose. This is correct for n. So this gives you n over 2 and plus 4 plus this n plus 1 here. Okay. So of course you can factor this out. So you get let's see. Is this correct? No. Let's see. Oh, no. Okay, made mistake. Factor the n plus 1. Okay. So this gives you n over 2. Or just factor this out. You get just n plus n plus 1. All right, so this is correct. So basically you get so this is so the induction, okay. So it's like just like replacing this n from this formula with n plus 1. And that's what we call inductions. All right, so and the formula for square is, let me finish this. For square is this formula here, n plus 1 to n plus 1. You can verify using induction. Right? So with this formula, let's continue this one here. Okay. If you continue with this one, So what we have so far is sum is, let's see, I should uh, okay. Paste. Okay, so then this gives you this is n plus 1 2n plus 1 over 6. Okay, so at the end you have this 1 over 6, put it outside, and you have there. That's the explicit formula for an. Okay. And the thing is, question: can you take limit? Because we know that the as n gets larger, the approximations gets better. Okay, so limit as n equals infinity an. So this limit 6. Okay, but this is limit of what you call rational functions, polynomial over polynomial. So only depends on the degree of the polynomial. So numerator you have cubed, and the denominator get also cube, right? So the limit is just the ratio of the highest highest power. So this is cube. So how many cube here? You have n times 2n, so 2n cube over there. Here we have just n cube, right? So you have 2 over that's the limit. Okay. So using these approximations, we see that uh, our scheme of approximations give you at the end this formula that you can compute the explicitly, right? And it has limit. The limit is 1/3. So conclusion is that what we say is this area over here is 1/3. Okay, so that's the basically what we are trying to do to find the area using approximations. Okay, looks complicated, right? So later on, we would like to find some simplifications. The question of course, can we simplify the computations? All right, questions?
Sir, can I ask about the midterm exam?
Mhm.
So we can already see the score, and we can also review which one's the correct answer and also the wrong answer. But it appears that the numbers that don't have the answers in the multiple choice haven't been revised. So there will be a
The
bonus, or
that should be corrected. That should be you are all gets gets credit for those two problems. So
So
count it as one.
okay, so we add one to our score, sir.
Uh-huh, uh-huh. But
Is
the
it
thing is,
only that?
I haven't revised the file yet because the formula is kind of complicated to do this on the LMS. So I have to do that manually on the Excel file.
Oh,
So you
okay.
won't see that on the grade is not reflected on the LMS. You see.
Okay, sir. But is it only one number
There's two.
oh, there's two.
Problem 5 and 14.
Oh, okay, so we add 2 points to our score in the LMS side, sir.
Not add 2 points, but for problem 5 and problem 14, it's counted 1-1 for you. That's full score for those two problems.
Oh, okay. Thank you,
Okay,
sir.
because some version of problem 5, problem 14 are correct, the answer. But some version of it with a combination of the parameters is not correct.
Okay, thank you, sir.
Okay, all right. So
Sir,
I'll
sir,
now set next week the grade
sir,
manually using Excel file. All right, sure. Go ahead.
I have a question. I checked one of my answers,
Uh-huh.
and it's not 5 and 14, but I don't think it's. I think I got mine correct, but it's not correct on here.
It's possible
It's-
because the we have three parts of the exam: part 1, part 2, part 3, and inside that parts, the problems is randomized, the order of the problem. So you might get a different order.
If I want to like notify the examiners, where do I talk about the questions? Do I just chat you or
Yes.
okay?
Send me
I'll send the two
uh,
questions that I got wrong.
just do the screenshot because the
Yeah, okay.
problem 5 that you do might be different from others
Okay,
others
thank you, sir.
5, right? Okay, any more questions? All right.
Sir,
Uh-huh.
I'll ask. So for my answer, I wrote like 5/6 in fractions, and the answer is 0.8333. But it's the same thing, and it says it's wrong.
Just send me the screenshot.
Okay, sir.